Okay, so what we're going to go through is polynomials. Polynomials was 2 chapters when we did this unit. It was expanding and then it was factoring. So we will review expanding first, factoring second. We've already done prime factorization and GCF. So we will start with expanding a monomial by a binomial. Okay, just need to get okay. So what we need to do is we need to get rid of the brackets. So you're going to look at what's in front of the bracket, which is a monomial, and you're going to distribute that into the bracket to get rid of the bracket. So you would take that 3x, and you're going to put the 3x inside. So 3x times 4x is 12x squared. 3x times negative 1 is negative 3x. Then go over to the plus 2x and distribute that inside. So 2x and 2x, 2 times 2 is 4, x times x is x squared, and then 2x times 6 is plus 12x's. From here we put our like terms together. So the x squareds would go together and you just take care of the numbers in front. So 12 plus 4 is 16x squared. And then our x's would be negative 3 plus 12. So you would type in on your calculator negative 3 plus 12 and you would get 9x's. Okay? When we're multiplying two binomials, so multiplying two binomials, how we do that is you circle the first term of the first bracket and you distribute that term into the second bracket. I'm going to put the invisible 1 in front of the x here. 2 times 1 is 2, and x times x is x squared. Then I'm going to multiply 2x times negative 3 to give me negative 6x's. I would then go and I would distribute in the plus 1. So plus 1 times 1x will give me plus 1x, and 1 times negative 3 will give me negative 3. Then put your like terms together. So there's no x squared, so bring that down. Negative 6 plus 1 would give you negative 5x's, and then bring down the minus 3. And that would be your expanded form for those two binomials. Okay, let's take care of a binomial times a trinomial. So it works in the exact same way. Circle the first term of the first bracket, distribute that inside. Edie, read me what you would get when you distribute that first term in. Okay. Perfect. Okay. When that term's distributed, go to that plus 4 and distribute that guy in. Izzy, read me what you would get when you distribute in the 4. Yes. Okay. Then put your like terms together. So see if there's any other x squareds y, and there's not. So if there's not, bring that down. Okay. Then check if there's any other xy's that would go together, and there is. So there's negative 15 plus 8. So you type in negative 15 plus 8, and you'd get negative 7xy. So those two terms would go together. There's no other x's, so bring down that 3x. There's no other y's, bring down the y, and bring down your constant. Okay, so that's what you would get for that guy. I'm going to give you some homework. And then I'll give you some to practice for about 10 minutes, and then we'll come back and we'll do the factoring questions. So what I would like you to practice is number 10 is a good one to practice. Number 11 is going to be a good one to practice. With 11, you don't have to do I. So you don't have to do a trinomial times a trinomial. So 10 and 11. These questions here, circle number 12, these would be your standard of excellence questions. And what we'll do is we'll do one of them together. Um, circle 13. So 13 is a good one. And what I want to show you with number 13, I'll get this one set up for you. So what it says is it says you have a cube. So draw yourself a cube. And it says that the side length of the cube is 3x plus 1. So what that means, a cube, all the sides are the same. So all of these would be 3x plus 1. It says write a polynomial expression for the volume of the cube, then expand and collect like terms. So we know from measurement that the volume of a cube is length times width times height. That would be 3x plus 1 times 3x plus 1 times 3x plus 1. I don't know if you remember how we did this in class, but what I told you to do is bring one of these down and then take care of, let's say, these last two binomials by expanding these guys into one bracket. So for example, circle that 3x and let's expand this one in. We would get 3 times 3 is 9x squared. 3x times 1 is plus 3x. Then over here, I would plus 3x. Then I would add 1. Within that green bracket, there's something I could simplify, so I will simplify. Maya, what would I simplify in this bracket? Yeah, to give me 6x's. We get this. And then Tessa, how would you go from here? Yes. So you'd circle the first term of this bracket and distribute that inside. When you're done that one, circle the 1 and get that put inside. And then collect those like terms. I'll give you a minute to finish that. And then actually we will do the shaded one because I do know that there's a shaded question on your exam. So we'll do that guy. And then I'll let you finish practice some for homework. Okay, let's do this last one together. You need to know how to calculate the area of a shaded region. So let's practice this and then you could practice the other ones on your own. So what we need to do for this is they want the area of the shaded region. So first what we need to do is we need to calculate the area of the big rectangle. Okay, area of a rectangle I know is length times width. So the big rectangle, it would be the length times the width. It'd be those two times each other. So 2n times 3n plus 1. I'm going to get rid of the brackets by distributing in the 2n. And the area of the big rectangle would be 2n times 3n, which would be 6n squared. 2n times 1 would be plus 2n. That's the area of the big rectangle. Then I would need to calculate the area of the small rectangle. And again, that would be length times width, and that would be n plus 1 times n minus 1. Okay, so let's distribute this to figure out what the area of the small rectangle would be. So n times n is n squared. N times negative 1 would be negative 1n. Over here, I'd have plus 1n. 1 times negative 1 is negative 1. Join those n's together, and they would actually cancel. Negative 1 plus 1 would give you 0 n's. So this would cancel, and we'd be left with n squared minus 1. Now I need to figure out, how do I get the area of the shaded? Who knows what I would do from here? Angelo, what would you do? The big, that's right. Once you have the big rectangle, if you subtract this area, you'd be left with a shaded. So what the formula would be, it would be area of shaded. So area of shaded is equal to the big area minus the little area. So like basically, let's say we calculated the big area to be 100 drops of paint. Like we need 100 drops of paint to calculate that. And let's say that this was 30 drops of paint. Then to get the area of the shaded region, 100 minus 30 would be 70. Now, here's where students make mistakes with this guy. When I take the big, the area of the big is 6n squared plus 2n. Then they write their minus, and here's what students will do. They're going to write minus, and then they're going to write the small n squared minus 1. What's wrong with the way this is currently written? What do I have to write it as? That's right. It's the big minus each of these terms. So how you take care of that is this goes in a bracket. Okay? And then what it would be, I'll just write it over here. Area of shaded, I'm going to bring down this 6n squared plus 2n. And then what do I do here? If there's a negative in front, what does that mean with what I do with the signs for this guy? Switch the signs, flip the signs. This will become a negative n squared, and this negative 1 will become a plus 1. Put your n squareds together, your like terms. 6 minus 1 would give me 5n squared. And then I would have plus 2n plus 1. And that would be the area of the shaded region. Okay? So I'm just going to... So just at the top of this page, let's write what the 4 methods of factoring that you need to know. So let's just write factoring. Now, on the exam, you could pretty much expect one question on each method. So factoring is definitely a bigger component than the expanding. So the first type of factoring is factoring by GCF. So what we do is whenever we get a question where we have to factor, no matter what, we always check to see if there's a GCF first. The second type of factoring was called PSA1, but more formally, that method of factoring is inspection. The third type is probably the most work. It was our PSA2, which is called decomposition. And the fourth method was probably what a lot of you preferred the most, and that was difference of squares. So I'll pretty much go through one of each type and then give you a variety where you could practice these. Okay, so for this first one, this is a GCF question. So you need to look at each term, which has a 30, a 12, and a 24, and you need to ask yourself, what's the biggest number that you could divide out of a 30, a 12, and a 24? 6. So the GCF is going to have a 6. Then you look at each term and ask yourself, does each term have x's? So this term has x to the power of 2, this term has 1x, and this term has 2 x's. You can always pull out the lowest power of x's if it's common to every term. So that would be x to the power of 1. Same with the y's. I've got 3 y's, 2 y's, and 1 y. You always pull out the lowest power, which is y to the 1. So what you would do is create a division bar under each term, and we're going to divide out that GCF. Whatever your GCF is, it always goes in front of your brackets, and then the answer to the division goes in the brackets. So 30 divided by 6 would be 5. You would do your quotient law for your x's. So x squared over x to the 1, you would subtract the exponents, and you would get x to the 1. And same with y's. You would subtract 3 minus 1 to get y squared. Minus 12 divided by 6 is 2. The x's would cancel. And when you subtract the exponents on the y, you'd have 1y plus 24 divided by 6 is 4. Subtract the exponents on your x's and you'd have x to the 1. The y's would cancel. And this would be your factored expression by GCF. So this would be one answer, one of my factors, and this would be my second factor. Okay, so GCF question. Let's look at PSA 1, which is called inspection. Okay, PSA questions always have 3 terms. They're always trinomials. Make sure your trinomials in descending order of x. So x squared, then your x, then your constant. Set up your little chart, product, sum, answer. And what we are looking for, this is a PSA 1 because there's a 1 in front. So if you multiply 1 times 12, we're looking for what two numbers are going to multiply to 12 and sum to -7. Now, how we did this was you always take that 12 and you always say, what are the numbers that multiply to 12? So 1 and 12 would multiply to 12, or -1 and -12. Divide 12 by 2. 2 and 6 would multiply to give you 12. So would -2 and -6. That would multiply to 12. Divide 12 by 3, and you get 3 and 4 will give you a product of 12. Same with -3 and -4. By inspection, you look at which two numbers would sum to give you the -7. So Richmond, what would be the answer by inspection? +3 or -3? Yep, -3 and -4. Because you guys, this would sum to give you 13, negative 13, 8, negative 8. This would sum to give you a 7 and a negative 7. We're looking for the one that gives us the negative 7, so this here. Inspection questions are nice. Set up your two brackets. Put an X at the beginning of each bracket. One X is going to get a minus 3, and one X gets a minus 4. It doesn't matter which one you write first. It could be X minus 4, X minus 3, and that would be the same answer. That's inspection. Let's look at what a decomp question would be. Okay, so for a decomp question, this is a PSA 2. You first try to GCF, and you first try to get rid of this 2 by dividing it out. Can't do it, so it becomes a PSA 2. You're going to look for the two numbers that are going to multiply to give you a product of 6 and sum to negative 5. So you take that negative 6 and you say, what multiplies to give you negative 6? So 1 and 6 will give you 6. To get a negative 6, it's either negative 1 and 6 or 1 and negative 6. Divide 6 by 2, 2 and 3. Now 2 times 3 will give you positive 6. We got to get a negative. Then figure out by inspection what your answer would be. So Amelia, what would my answer be to give me the negative 5? Negative 6 and 1. So 1 and negative 6. Now, decomp, we break that middle term. I'm going to be a little bit strategic though. What number am I going to write first, seeing that I have a 2x squared that I lead with? 6. I'm going to put the negative 6 first. So I'm going to say break down negative 5x's using that answer. So how do I get negative 5x's? Well, negative 6x plus 1x gives me negative 5x. Bring down that negative 3. Bring down that front term, which is a 2x squared. You'll always get 4 terms. Drew, what do I do with 4 terms? Yep. Before, where do we split it? In the middle. You split in half and you group factor. So from those 2 terms, take out your GCF. Christian, which would be what? What can I take out of a 2x squared and a 6x? A 2. Anything else? You could take out an x, because you've got x to the 2 and x to the 1. Your GCF would be a 2x. Do the division. 2 divided by 2 is 1. X squared divided by x is x, minus 6 divided by 2 is 3, and your x's would cancel. Go over to the right-hand side. Read, what could I factor out of a 1x and a 3? A 1. What is the sign? Like, do I take out a plus 1 or a minus 1? Yes. You take out whatever sign is in front of that third term. So I would factor out a plus 1. That goes in front of your bracket, answer in the bracket. 1 divided by 1 is 1, bring down the x. Negative 3 divided by 1 is negative 3. Remember, for decomp questions, your check is that these two brackets are identical. So one of my factors is 1x minus 3. My other factor would be 2x plus 1. Okay, that would be your decomp. Let's do difference of squares, which is our last one. Difference of squares is 2 terms. These can be square root 2, is you set up 2 brackets. You take the square root of 64x squared. What would the square root of that be? So say to yourself, what's the square root of 64? 8. What's the square root of x squared? X. Then take the square root of 49 and you'd get 7. One of these factors will get a plus and one of these factors will get a minus. Okay? I'm going to give you a more complex difference of squares that you might see. Write this one. 16 x to the 4 minus 1x squared. I could take the square root of 16. I could take the square root of 1. The square root of 1 is 1. I could take the square root of x to the 4, and I could take the square root of x squared. However, before you factor by difference of squares, what do you always need to check? A GCF. What is the GCF of this? It's x squared. Okay, so first thing I need to do is I need to divide out an x squared. That goes in front of the bracket. Answer goes in the bracket. So 16 x to the 4 divided by x squared would be 16. Subtract those exponents and you'd get x squared minus, those x squareds would cancel and I'd bring down the 1. If this was a multiple choice question, for sure that would be a distractor as an answer, and a lot of students would choose this one. This guy's not fully factored. What else can I do? Izzy, what would you do? Yes, this would be a difference of squares. So let's bring down that x squared. Okay, that was one of my factors. But then always look at this bracket and say, can I do something further? And I could take a difference of squares here. So the square root of 16, actually, are we going to further be able to factor that? No, we won't. Square root of 16 is 4x. Square root of 1 is 1. 1 gets a plus, 1 gets a minus. At first, I was thinking, oh, this could still be a difference of squares. But you know what we can't take the square root of? The x. So this would be the final answer for this guy. Okay. I'll show you what your practice problems would be, and there's one that we'll do together that's sort of like this. Oh, it's going to be on your next, okay, 15 on here, 16 on here. Now this would be inspection or PSA number 1. But I want you to take out the other year-end review package I gave you. Jack, do you have one? Okay, open up to page 7. So on the second review package, it says year-end review on page 7. You could do number 2. Cross out C. I don't need you to do C. Do number 3 and do number 4. And the one I want to do with you is D, 2D. So it's 16 a to the 6 y squared minus 49. Two terms separated by a minus, it's going to be a difference of squares. I can't GCF anything out of here. So we would set up our two brackets, and we would say we need to take the square root of this guy. Now the square root of 16 is nice and easy. It would be 4. Over here, the square root of 49 is easy. It would be 7 and 7. A to the 6. Does anybody know what the square root of a to the 6 is? If you can't think of it, what are you thinking, Angela? It's a to the 3. But here's how you'd figure this out. A to the 6, the square root of a to the 6 would be this. right? That's the square root of a to the 6. And then, remember what we did is we circle pairs. For every pair, how many did we always take out? 1. So an a would come out, an a would come out, an a would come out. That leaves me with a cubed, not 3 a's. It would leave me with a times a times a, add the exponents, and you'd get a cubed. So the square root of a to the 6 is a to the 3. The square root of y squared is y. 1 would get a plus, 1 would get a minus. Are you good with that? Okay.